Hello, this is Mrs. Ward, and I am going to go over the review worksheet for section 4.3. The first question says, determine the exact values of the six trig functions of the angle theta shown in the figure below. So the first thing I'm going to do is I'm going to have to find this missing side. So to find this missing side, I'm going to call this B for right now. And I'm going to do the Pythagorean theorem. Just a reminder that when I have this triangle, these are my legs. So I'm going to do b squared, a leg, plus 17 squared, another leg, is equal to my hypotenuse, which is 135 squared. So if I do that on my calculator, I'm going to take, well, let me do this first. I'm going to say b squared is equal to 145 squared minus 17 squared. So I'm going to have 145 squared minus 17 squared. And I get this huge number, and then remember that's b squared, so I'm going to take the square root of that, grab it, that'll work, and I get 144. So b is equal to 144. Since this doesn't talk about quadrants or anything like that, I'm just going to go ahead and assume that it's a positive angle. Now, remember when I'm doing this problem, I'm looking from this angle up here. I know we have to show triangle looking down here. But this angle theta is actually marked up here. So to find my sine, I'm going to do the opposite of the hypotenuse. So that's going to be 17 over 145. I'm going to go ahead and do its reciprocal cosecant by writing 145 over 17. To find the cosine, I did the adjacent over the hypotenuse, so that's 144 over 145. And then I'm going to do the reciprocal secant, which will be 145 over 144. Finding the tangent is the opposite over adjacent, so that's going to be 17 over 144. And the reciprocal is going to be 144 over 17. And I could do a quick check and divide this sine by cosine and see if I can get that. Thank you, so I know I have the tangent correct. Okay, the next one says sketch the triangle and determine the exact values of the six trig functions of the angle theta given below. So tell me that the tangent is 24/7. So I'm just going to sketch a triangle. I'm going to assume that's in the first quadrant. That's why I drew it like that. Here's going to be my theta. My tangent is my opposite, so 24, over my adjacent, which is 7. Now I'm going to have to use the Pythagorean theorem to find my missing side here, which I'll call HR or whatever. So I'm going to say 7 squared plus 24 squared is equal to 8 squared. So I'm adding these two because I have the two legs. So I'm going to say 7 squared plus 72 squared. 7 squared plus 24 squared is equal to that large number, and I need to take the square root, so I'm going to take the square root of that number, and I end up with 25, and that's squared. So this will be 25. Now to find the sine, I'm looking from this angle here, so I'm doing the opposite of the hypotenuse, so that would be 24/25. The reciprocal cosecant will be 25 over 24. Cosine is the adjacent, that's the angle that helps form this side that helps form that angle, so 7 of the hypotenuse, which is 25. The secant is a reciprocal of that, so 25/7. The tangent they gave me was 24/7, and the reciprocal would be 7/24. But again, if I look at this triangle, my adjacent are opposite. That's how I get my tangent. All right, looking at the next one, it says determine the exact values of the six trig functions of the angle theta shown in the figure below. So here, I'm missing this side here, so I'm going to say b squared plus 3 squared is equal to 10 squared, because remember 10 is the hypotenuse, it's the side opposite of that right angle. So I'm going to say b squared is equal to 10 squared minus 3 squared. And this is, we can do this in our head, this is 100 minus 9, so b squared is equal to 91. So b is equal to the square root of 91. Now to see if I can pull anything out, if it has any perfect factors, I'm going to hit menu, number, and then I'm going to go to factor, and I'm going to type in 91. Hit enter. And I have 7 times 13, so 91 factors is 7 times 13. The problem is neither of those factors repeat. So I cannot take the square root of either of one of them. So I'm going to just go ahead and use the square root of 91 as the square root of 91. Now when I go to find my 6 trig functions, I'm going to do the sign, which is the opposite. So the square root of 91, because now we're looking from this angle here. So the square root of 91 divided by my hypotenuse, which is 10. To find the cosecant, I'm going to take the reciprocal of that. So I'm going to have 10 over the square root of 91. Do not leave it like that. You need to rationalize. So multiply by the square root of 91 over the square root of 91. The numerator will be 10 times the square root of 91. The denominator is just 91. To find the cosine, I'm going to do the adjacent, which is 3, over the hypotenuse, which is 10. And then the secant will be the reciprocal, which will be 10/3. To find the tangent is the opposite over adjacent, so the square root of 91 over 3. To find the cotangent, I'm going to flip that, so 3 over the square root of 91. Then I have to rationalize, and I'm going to end up with 3 times the square root of 91 all over 91. And that's how I find my 6 trig functions. Number 4 says, sketch the right triangle corresponding to the trigonometric functions of acute angle theta. So it's telling me it's acute angle theta, which tells me if I'm doing it on my grid, the angle has to be less than 90. So it's going to be in the first quadrant somewhere. Find the other 5 angles. And it's telling me that the sine is 2/9. So if I'm looking from here, the sine is 2/9. So the opposite is 2, hypotenuse is 9. Obviously, my triangle doesn't draw the scale, but that'll work. I'm going to call this b, so I'm going to say b squared plus 2 squared is equal to 9 squared. So b squared is equal to 9 squared minus 2 squared. So 9 squared minus 2 squared. And I get 77. Now I'm going to take the square root of 77, which I believe is going to be a decimal. So now let's say do menu number factor, and let's do 77 to see if I can pull out any perfect squares. And 77 factors is 7 times 11, so nothing repeats, so I can't take anything out. So b is going to end up being the square root of 77. So to find the sine, I'm going to put the same here, 7. Now to find the sine, I'm going to do the opposite of a hypotenuse, so that's going to be 2/9. The reciprocal is going to be 9 over 2. And then to find the cosine, I'm going to do the adjacent, which is that square root of 77 over my hypotenuse, which is 9. To find the secant, I'm going to do the reciprocal, so I'm going to have 9 over the square root of 77. Rationalize, and I'm going to have 9 times the square root of 77 all over 77. The tangent is the opposite over adjacent, so 2 over the square root of 77. Now I have to rationalize that, and I know I have to rationalize that, but while I'm here, before I rationalize it, I'm going to go ahead and do the reciprocal and write the square root of 77 over 2. That way I'm doing the reciprocal in the most simplified form. Now to rationalize, I'm going to do square root of 77 over square root of 77. And I get 2 times the square root of 77 all over 77. And that is going to be my 6 trig functions. All right, moving on to the next one. It says use the trigonometric and then use to transform one side of the equation to the other. This is just telling you that we're working in the first quadrant, so everything's going to be positive. That's all that's telling me. So if I have tangent times cotangent, I have different ways of doing this, but probably, and I'm going to do one like, there's many ways you can do it. What you have to remember is that this equal sign is kind of like a wall. You can't cross anything over. You can't add, subtract, multiply, divide by both sides. But for me, I would probably do a tangent sine of theta over cosine of theta, because that's what tangent's equal to. And then the cotangent is cosine of theta over sine of theta. And I'm trying to show that that's equal to 1. Well, when I write it like that, it's very easy for me to see that the cosine simplified, the sine simplified. So if they simplify, I still have a number there. These are all like 1 and 1, 1. So I end up with 1 times 1, which is 1, over 1 times 1, which is 1. So I get 1 is equal to 1. And that's it. I'm done. That was pretty easy. The cosecant, I'm going to write as 1 over sine theta. And then the secant, I'm going to write as 1 over cosine theta. And I'm trying to prove that it's equal to the cotangent. I might go ahead and write cotangent as cosine theta over sine theta. Because if I don't see anything that I know, I'm probably going to change everything in terms of sine and cosine. As long as I don't cross this line, I can work with both sides as long as I work independently on the left and independently on the right. Okay, this one is a division, so remember I'm going to keep the first fraction. I'm going to switch that division to multiplication and flip the denominator, so I'm going to write cosine over 1. Prove that that's equal to cosine theta over sine theta. So here when I multiply, I'm going to take 1 times cosine theta, which is cosine theta, and then sine theta times 1, which is sine theta. So now I have the left side looking like the right side, and that's the goal of this exercise, is to get the left side to look like the right side, and they have to look exactly right. Okay, the next one, I have sine theta times secant. So again, sticking with my plan of changing everything in terms of sine and cosine, secant is 1 over cosine theta, and I might want to write the sine over theta over 1 so I can clearly see where my numerators and my denominators. My tangent is, remember, sine theta over cosine theta. Now when I multiply, I'm going to have sine theta times 1, which will be sine theta, 1 times cosine theta, which will be cosine theta, and that now I can show that the left side is equal to the right side. Okay, number 6 asks you to read. So a 55-meter rope is tied to the top of a tree. So let me tree. I have a 55-meter rope. So this will be my rope that is 55 meters. 55 meters top to the tree. If the angle the rope makes with the ground, so obviously this would be the ground, and I'm going to, the angle the rope makes with the ground is 47 degrees. Oh, you know what? This is not where my rope is. My rope is 55 meters long. I'm tying it to the top of the tree this way. Yes. How tall is the tree? Because I'm looking for how tall the tree is. Draw a diagram for the situation to solve the height of the tree. So you have to draw us this picture. Now, do you need the tree? No, I'm just being artistically creative. But here's a simplified version of what you need. So if I have that and it wants me to solve for the height of the tree, I have this angle here, 47 degrees. This is my hypotenuse, and this x is opposite of the angle that I'm giving. So the trig function that deals with the opposite hypotenuse is going to be sine. So we say the sine of 47 degrees is equal to the opposite of the hypotenuse. To solve this, I am going to multiply both sides by 55. So I'm going to take 55 times the sine of 47 degrees, and that's going to equal x. So on my calculator, notice that I'm in radians because I live in radians and trig. So I'm going to have to make sure I tell my calculator that the angle that I'm talking about is in degrees. So I'm going to put in exactly what I had. So 55 times the sine of 47, and then I have to make sure that I put that degree symbol in to tell my calculator that this number that I'm giving, 47, is actually in degrees and not in radians. I'm going to hit enter, and I get that 40.2245. So x is equal to 40.225. And it doesn't tell me a certain number of decimals, so I'm just going to round it to 2. So I'm going to say 40.22. And my units are going to be the same units as my rope, which are going to be meters. And that is going to be the height of the tree. Okay, and the last one says find the values in degrees, and it says theta is between 0 and 90, or 0 and pi over 2. That's just telling me that I'm looking in the first quadrant. I'm only picking values that are in the first quadrant and 11th quadrant. So if I do that, I'm looking at my unit circle and I'm just focusing on this first quadrant. That's all I'm looking at. So this is asking me, when is the sign equal to 1/2? So at what ordered pair is my y value equal to 1/2? Well, if I have my unit circle, if I wrote down my unit circle, I can see here at this first angle, 30 degrees, my y coordinate's 1/2. So the answer, theta, is going to be either 30 degrees or pi over 6. See how this says and? That means I must give both. Okay, the next one, it wants the cosecant of the square root of 2. Well, we know that when I write these, it's cosine, sine. So my cosecant isn't on there. So what I'm going to say is, well, the cosecant is reciprocal of sine. So if the cosecant is equal to the square root of 2, that means the sine of theta is equal to 1 over the square root of 2. And then I probably rationalized. So the square root of 2 over 2. So this is asking me, when is the sine, or when is the y value equal to the square root of 2 over 2? And if I'm writing down my unit circle, that happens at 45 degrees. Or pi over 4. Again, I have to give both. This one's asking me, when is the cosine, or when is the x value equal to 0? Well, here at 0, my ordered pair is 1, 0. The x value is 1, so it's not there. If I go up here, my ordered pair is 0, 1. The x value is 0. So it's going to be this angle here. So theta is going to equal 90 degrees or pi over 2. Secant is undefined. Secant is a reciprocal of cosine. So if the secant is undefined, let's think about this. If the secant is undefined, that means I had to division by 0. Probably a 1, because that's the only number that goes with 0 in my unit circle. Which means that the cosine of theta had to be 0. 0 and 1, however you want to look at it. So when is the cosine equal to 0? That's the same place as here. So that's going to be theta would equal 90 degrees or pi over 2. When is the tangent equal to the square root of 3 over 3? So I'm just going to draw my other one, which is 1/2 square root of 3 over 3. In order to get a tangent, remember tangent is sine over cosine. So if I do this one, let's try this one first. Like, I know it's not pi over 4 because that would be dividing the same thing by the same thing, which is 1. This one, if I take 1/2 and divide it by the square root of 3 over 2, multiplied by the reciprocal, I do get 1 over the square root of 3, which will rationalize to this. So it is going to be that first angle of pi over 6, 30 degrees. If I would have tried the other one, if I would have tried this angle up here, I would have ended up with the square root of 3 over 2 over 1/2, which would have been the square root of 3. So that wouldn't work. And then the last one, cotangent is equal to 1. Cotangent, remember, is cosine of theta over sine of theta. In order for me to divide a number and get 1 as an answer, that means these two have to be the exact same number. And the only time that happens is right here. So I'm going to say theta is equal to 45 degrees or pi over 4. And that's it for this video. If you have any questions, come see me or ask in class. And I hope this helps.